Okay, this is test number 2, question number 4 on the practice test. And the question is, arrange the following elements in order of decreasing, and I underlined decreasing, because I can ask any question and it might be decreasing, it might be increasing, but you're going to need to answer such questions on the test, of decreasing covalent radii. And the list is tin, nitrogen, oxygen, silicon, phosphorus, and cesium. So the general trend that we have to take into account here is what happens to the size of the atoms as we proceed across the periodic table. And there are two things we have to know. As we go from left to right, in general, the size gets smaller going across a row. And as we go down a group, the size increases. And that's the big general trend. Now the trend we have to take into account after that is there's two exceptions. And those two exceptions arise when we're coming down the group. As we go from aluminum to gallium, instead of getting larger, it actually gets smaller. And that is called the D block contraction, because of the presence of all these D block elements. There's 10 elements in here. And that means I've got 10 more protons in the nucleus, 10 more positive charges in the nucleus. And these are neutral, the charge is compensated for by the d electrons, which are spatially extended, have a lot of electron density out way beyond the nucleus, and therefore they don't screen effectively nuclear charge. From the p electrons and gallium, which are the electrons going to be going into a p orbital, is not screened effectively from that nuclear charge. And since I've had this huge increase, that means this gallium experiences more positive nuclear charge, and therefore there's a decrease in size. It just occurs here. And that's known as the D block contraction. The other one is the F block contraction, otherwise known as the lanthanide contraction, and that happens when we're going from yttrium to lanthanum. And that is for the same reason. It's because we have all these F elements, the lanthanides, with their F electrons, which are even more spatially extended and don't screen. So for the same purpose, and I've got 14 of those. So I've got 14 more positive charges, which is going to give me the lanthanum is going to experience a much more nuclear charge that's not being shielded, and therefore there's a lanthanum contraction. And so those are the two things we have to take into account for the general trends. Now, the question is going to be such that these exceptions are not going to probably enter into it. I'm going to have the order such that we're going to start with the one that's furthest up to the right-hand side, and that's going to be the smallest. And I'm going to go to the left and down, and to the left and down. And that would make it so, such that you can unambiguously assign it. Okay, and so we're going to look for which one's the furthest up to the right. Well, I look here, and oxygen would be the one that's the smallest. And now we're asking for a decreasing covalent radii. So which one's going to be the largest? I come all the way down, and I look which one's furthest down to the left, and that would be cesium. So I'm going to start my sequence with cesium is larger than, and I go from cesium to which one is next in my hit parade. I don't have any more here. I get to 10. I go from cesium, I go up one, I come over here to 10. And that looks like that's the next one in size. So I go from cesium to 10, which is larger than, and now I've got cesium 10, I'm going to go around here. Which one, are there any more in this row, no. I go up directly from 10, I have silicon. So silicon's going to be larger than, right adjacent to that is phosphorus, which is itself going to be larger than, I go directly up from phosphorus, nitrogen. And nitrogen is obviously going to be larger than oxygen. And now we've arranged them in the appropriate sequence.